So looking at part A of this question, they are giving us a certain integral negative 6 to 5, and they're asking us the value of a different integral, negative 6 to negative 2. So then one thing that we notice that's weird right away is the graph does not have a negative 6 on it. Negative 6 is going to be way over here. So how am I supposed to know anything about the integral from negative 6 to 5? Well, I have to think about how these two could sort of interact with each other. If I have negative 6 to 5, it's the integral from here to here, and then negative 6 to negative 2, the integral from here to here. Could I combine those somehow? Well, you can, because the integral from negative 6 to 5 of f of x dx is equal to the integral from negative 6 to negative 2 of f of x dx plus the integral from negative 2 to 5 of f of x dx, right? That's just taking this interval and breaking it up into two parts, saying basically if I have some function and I'm looking at an integral from negative 6 to 5 and I break it at negative 2, then the total area, negative 6 to 5, is equal to the sum of the two smaller areas, negative 6 to negative 2 and negative 2 to negative 5. So if I add these two areas, I get this area, I get the big area. That's what this says. All right. And then I can put together the fact that I know what the integral from negative 6 to 5 is. They told me that's 7. The integral from negative 2 to negative 6 is what I'm trying to find out. And the integral from negative 2 to 5, well, that's what I've got the graph of, is the integral from negative 2 to 5. So then I just use the graph to find the integral. So when you're doing that, there's lots of different ways you can do it. One way you can do it is just take each piece one piece at a time. So, you know, I've got this little triangle is 1/2. This little triangle down here is going to count, remember, as negative 1/2 because it's below the x-axis. So I have 1/2 and then minus 1/2. And then this is a quarter, but it's below the x-axis, so minus a quarter. And then this is another quarter, it's above the x-axis, so plus a quarter. So you can write all that out. But by the way, another important way to sort of shortcut this is to notice that these two areas are the same, so they cancel out. And these two areas are the same, one above and one below the x-axis, so they cancel out. So instead of writing all this out, I could just say, you know, I already know that those pairs of areas are going to cancel. So another thing you can do then, so you're left with this area in here, and then the semicircle area. So when I'm looking at this area, all right, you can do trapezoid formula on that if you want, but really look for, you know, like this triangle, I could turn it down and put it down here. Look for geometric simplifications. So I know that that trapezoid is equal to this rectangle, and the rectangle is 1/2. So that trapezoid's area is 2. So if you can sort of do that quickly, you can save doing a trapezoid formula, and anything that saves time is good on this test. Now the thing you're left with is this semicircular area, or whatever you want to call this, it's like the difference between a square and a quarter circle, right? This area in here. So what that is the area of the square minus the area of the quarter circle. So the area of the square is 9 because it's a 3×3 square, and then the area of the quarter circle that I'm subtracting out, not because it's below the x-axis, but because it's not part of my shape, right? So I'm subtracting out this circle of radius 3, but it's only a quarter of the circle, so 1/4, and then pi times 3 squared. Remember, pi r squared is one of the few formulas that they actually expect you to remember for the BC exam. If we had sort of a more complicated shape, they would probably give us the formula. But, you know, triangles, trapezoids, rectangles, circles, they expect you to know all those geometric formulas. So now all we have to do is solve this. So I end up with 7 equals the integral from negative 6 to negative 2 of f of x dx plus 11 minus 9 pi over 4. That's just combining these two, and then subtract that over to the other side. So my 7 minus my 11 is going to be negative 4. My negative 9 pi over 4 I put to the other side is going to be plus 9 pi over 4 equals the integral from negative 6 to negative 2 f of x dx. So I cannot just leave it like this, even though I don't have to simplify things. All right, I can't leave it like this because I've not isolated the solution to the problem. Once I've isolated the solution to the problem, I don't have to simplify anymore. So I could have left this, you know, 7 minus 11 plus 9 pi over 4, but I was pretty confident that I knew 7 minus 11. All right, so that's part A.